Chips used to be small, quiet, invisible. Today, they act like geopolitical pressure points. Every AI system, every missile, every satellite, every cloud server depends on circuits thinner than a strand of DNA. The world now competes for nanometers. Because whoever controls the chips, controls the directions of technology, security, and global power. This isn't a trade war. This is a new Cold War, one fought through fabs, tools, and knowledge. Chapter 1. Why chips became the new oil. Semiconductors run modern civilization. Phones, cars, factories, hospitals, planes, banks. Even your coffee machine depends on chips. But power is not spread evenly. Leading-edge chips drive AI, weapons, and supercomputing. Mature node chips run cars, appliances, and industrial gear. Both matter. But only one decides the future of technological leadership. Shrinking nanometers creates leverage, faster models, lower energy use. Smaller devices, stronger military systems. That leverage transformed chips into the most strategic resource of this century. Chapter 2. Inside the chip stack. A modern chip looks simple. It is not. Imagine a tower where every floor depends on the one below it. If one floor fails, everything collapses. Floor 1. Architecture design. NVIDIA, Apple, AMD draw blueprints with billions of transistors. They imagine the logic, but they don't always manufacture. Floor 2. IP and EDA software. ARM licenses the instruction set powering global devices. EDA tools, Cadence, Synopsys, verify everything. Without these tools, you can't design even a basic chip. Floor 3. Manufacturing equipment. This is where industrial magic lives. ASML writes circuits with light. Tokyo Electron and Applied Materials shape atom-thin layers. Floor 4. Materials. Ultra-pure silicon wafers. Photoresist that reacts to extreme light. Rare gases for lasers. Chemicals so pure they ruin a batch if a single molecule is wrong. Floor 5. The fabs. TSMC, Samsung, Intel run cleanrooms cleaner than surgical theaters. A particle of dust can cost millions. Yield is a survival game. Floor 6. Packaging testing. Chips are cut, stacked, wired, tested. Advanced packaging combines multiple chiplets into one engine. A perfect wafer can still fail here. This entire tower is fragile, globalized, and nearly impossible to rebuild quickly. Chapter 3. How we entered the semiconductors Cold War. The smartphone boom started the pressure. Cloud computing multiplied it. I made it explode. Governments suddenly realized, economic growth runs on chips. National security runs on chips. Military advantage runs on chips. Supply chains collapse without chips. What followed? Export controls. Sanctions, subsidies, domestic fab incentives. Race for talent, strategic stockpiles. But here is the brutal truth. You cannot rush semiconductor dominance. A leading-edge fab takes years. Talent takes decades. And mistakes cost billions. This Cold War moves slowly on the outside, but at sprint speed inside every industry. Chapter 4. The choke points that decide everything. 1. EUV lithography. The rarest industrial tool ever built. The only gateway to leading-edge chips. Without it, you stop at older nodes. One company dominates this gate. 2. Leading-edge foundries. TSMC and Samsung form a duopoly. Building their capabilities took decades of failed wafers, process refinements, supply chain discipline, customer trust. Money alone cannot copy this. 3. EDA tools. Designing a modern chip without these tools is impossible. Cut-off access, and chip development freezes before manufacturing. These choke points never appear in headlines, but they silently determine who moves forward and who stalls. Chapter 5. The Rising Cost of the Cold War. As countries duplicate fabs, tools, and research labs, one thing becomes obvious. Resilience is expensive. Redundancy is expensive. Geopolitical insurance is expensive. Duplicated factories mean higher chip costs. More controls mean longer timelines. More risk means more price shocks. This is the economic tax of the semiconductor era, and consumers always pay the bill. Chapter 6. Winners in the New Landscape. Countries that control any part of the stack, fabs, tools, IP, materials, gain enormous leverage. Companies with leading-edge chips shape the future of AI and cloud computing. Nations securing packaging and materials early avoid bottlenecks before they appear. Foundries with strong yields dominate cost curves and win every major contract. These winners collect talent, capital, political influence, and long-term industrial power. Chapter 7. The Losers. Countries fully dependent on imported chips face higher prices, longer delays, vulnerability during crises. Companies hit by export controls lose roadmaps. Startups face soaring costs and limited foundry slots. Consumers see higher prices for cars, electronics, and AI services. Inflation doesn't always begin with oil. Sometimes it begins with wafers. Chapter 8. What it means for consumers. Everyday life becomes more fragile. A shortage at one factory can delay smartphones, laptops, game consoles, cars, medical devices, home appliances. Cars now contain dozens of chips. One missing component can park thousands of vehicles. AI access is hardware gated. No chips, no training, no inference, no progress. Your digital life depends on an industry you never see. Chapter 9. The Bigger Picture. This Cold War is not about domination. It is about endurance. Fabs will rise. Tools will evolve. Policies will shift. But knowledge, the deep, tacit process knowledge, moves slowly. Whoever accumulates that knowledge will set the rhythm of global technology for decades. A chip fits on your fingertip. It carries the weight of economies, industries, and national power. This new Cold War will be long. It will be expensive. And it will shape the future more quietly than any headline can show. Because in a world built on silicon, whoever controls the chips controls the tempo of the future. Stay curious, stay sharp.